Alright, good afternoon everyone. My name is Professor Davis. I will be your professor for IET301 this summer. And after reviewing homework number 1, I felt it was probably a pretty good idea to go ahead and walk you through my expectations for the homework and some of the problems. With this being the homework out of Chapter 2, one of the things that you'll probably notice is that the author is throwing some of the information at you that you haven't necessarily talked about yet. And I just wanted to kind of help you guys out with that to make sure that you didn't run into this assignment and just get totally lost in the middle of the solution process. You will notice on the assignment or in the course that the two graded components, namely the chapter quizzes and the homework assignments, tend to be scaled slightly different. The chapter quizzes tend to be problems that you can fairly quickly do, 5, maybe 10 minutes tops. However, a lot of these homework problems will be more time consuming, so just be aware of that. When you go through and do these assignments, a good portion of the assignments, and more so as you go through the quarter, will be intended for Excel, such as problem number 1 and problem number 8. Early on, if you want to do some of these problems using Excel, that's more than acceptable, but I am fine with you just doing these problems on engineering paper and scanning that engineering paper and submitting it online if that's what you choose to do. Keep in mind that some of these problems specifically say use Excel, so make sure that you follow directions as you're going through the assignment. So let's go ahead and start buzzing through a few of these. Now, just a quick note, I will not be reviewing all of these. If there are problems that are duplicated, I will be reviewing the first problem, and then the second problem will be left for you to solve. A good example of this is problem 1 and 8. Problems 1 and 8 are both asking you to draw a cash flow diagram given the information that you're provided. I will go through problem number 1 with you here, and I will leave problem number 8 for you to figure out on your own. So on problem number 1, we're given a cash flow table which indicates the cash flow from year 0 through year 6. Keep in mind that if the cash flow is in parentheses, it is indicating a negative cash flow and therefore will be pointing south. If it is a positive cash flow, it will not be included in parentheses and therefore it will be represented as a upward vector. So as we go through the table here, we see that in year 0 we have a negative cash flow of $15,000. In year number 1 we have a positive cash flow of $3,000. In year number 2 we have a negative cash flow of $4,000, and then a positive cash flow in years 3, 4, and 5 of $8,000, $10,000, and $2,000 respectively. And then finally a negative cash flow in year 6 of $1,000. So this gives you a good idea of what your cash flow diagram should look like. Keep in mind that in the homework assignment it does ask you to do this in Excel, and for those of you that have taken a chance to look over the assignment, you see that there is in fact an Excel tutorial already posted on Canvas that illustrates how to go through and create these cash flow diagrams using Excel. Alrighty, so as I go through here, if on any of these problems you have questions, feel free to stop by my office. During the days after 2 o'clock tend to work better for me. If you do want to stop by, it's probably a good idea to go ahead and send me an email or give me a call, leave me a voicemail. I do get back with people a lot quicker if they email me, but either form of contact is fine. Before 2 o'clock doesn't work for me because I'm doing a lot of prepping for my other classes and everything else, so please, if you do need to contact me to go over some of these problems, stop by after 2 o'clock, Monday through Thursday. Okay, on problem number 2, we are looking at the sizing factor for a particular problem. Now, it gives us some information here. It tells us that in 2004, we had a piece of equipment that cost $100,000 to purchase, and that 4 years later, another company decides to purchase an equivalent piece of equipment, and they want to know how much it should cost them. So one of the things that you see right away is that we need to go through and determine what the current value of that piece of equipment is. This is something that will be talked about extensively in Chapter 3, but in Chapter 2, the author is just kind of jumping the gun on. So there's a couple of ways that we can do this. We can go through and determine the future value, which represents the value of the piece of equipment in 2007. It will equal the present value times 1 plus the interest rate raised to the number of years that have passed. So in this case, we have a present value of $100,000. We have a 1 plus the interest rate to give us 1.03 raised to the 4th power, and we see that the value of that piece of equipment in 2007 is $112,550. Okay. Now, an alternate way of doing this is to use the tables that are available in the book. In the book, we can see that this is set up, or can be set up as the future value equals the present value times the value out of the table. This particular setup works extremely well because we can almost interpret it algebraically. If you notice here, the P cancels the P, leaving us with the F. So the present value is going to cancel the present value in the parentheses, and the only thing left to find is the future value. This allows us to help keep straight what we're finding. So what we would do is we'd plug in $100,000 into the present value. We'd look in our tables that are available in the book to figure out what the book says the future value will, or future value multiplier will be, given an interest rate of 3% and a term of 4 years. Again, we'll talk about that considerably more in Chapter 3. After we go through, then we use this as our cost of the first piece of equipment. I'll call it cost A. So our power sizing equation says that cost A is to cost B as the size of A is to the size of B raised to our size factor. So by algebraically rearranging that, we find that cost B, which is what we're trying to find in this problem, is equal to cost A divided by this term. In this case, it is the $112,550 divided by, I went and canceled out some zeros here, so this would be 10,000 over 15,000. I just crossed out all the zeros to give us 1 over 1.5 raised to the 0.59, and that gives us 142,969. Now, keep in mind that this is an approximation. And also keep in mind that this is a whole lot of significant figures for an approximation. So it would probably be perfectly acceptable to say that this is about $143,000. If you were to take your this number to your manager and say that the expected value of this piece of equipment is $142,969, that would probably be just a bit too much accuracy for this estimate. So keep that in mind. We will be breaking these solutions up into segmented videos just because of the file size. So at this time I will go ahead and post this video. go ahead and do the videos for the other problems, and then hopefully by the end of the day I'll have all of the videos posted for homework number 1. So as I said, if you have any questions, please let me know. Talk to you later.